The Darter, officially known as the Agile Darter, represents one of the most advanced short-range air-to-air missile systems developed in the Southern Hemisphere. Designed through a collaboration led by South Africa's defense industry, the missile reflects decades of research into modern aerial combat, where speed, agility, and precision determine survival. From the moment it is viewed from the front, the missile communicates its purpose clearly: domination in close-range air combat. Seen from the front, the most striking feature is the infrared imaging seeker housed in the nose. This dome is carefully shaped and manufactured to allow maximum sensitivity while protecting the internal sensor from extreme aerodynamic heating and vibration. Unlike older heat-seeking missiles that could be fooled by flares or background heat, this seeker is designed to recognize and track the actual shape and movement of an enemy aircraft. The nose cone's smooth geometry is not only about aesthetics, it minimizes drag and ensures stable airflow at high speeds, allowing the missile to maintain accuracy even during aggressive maneuvers. From the side view, the Darter reveals its balanced and compact profile. Every section of the missile is proportioned for efficiency. The guidance section near the front houses advanced electronics that process targeting data in real time. Moving further back, the central body contains the warhead and control systems, while the tail section integrates the propulsion and steering mechanisms. The fins, carefully positioned along the body, are designed for extreme agility. These control surfaces allow the missile to change direction almost instantly, enabling it to pursue targets that attempt sharp evasive maneuvers. The side profile also highlights the missile's relatively short length, a design choice that allows it to be carried easily by modern fighter aircraft without compromising aerodynamic performance. Viewed from the rear, the missile's propulsion system becomes the focal point. The exhaust nozzle is engineered to withstand intense heat and pressure generated by the solid fuel rocket motor. Subtle details in the nozzle design indicate thrust vectoring capability, a key feature that gives the Darter its exceptional maneuverability. Instead of relying only on fins to steer, the missile can redirect thrust itself, allowing rapid turns even at low speeds or high angles of attack. The rear view often shows heat-resistant materials and reinforced structures, evidence of the harsh conditions the missile is built to endure during launch and flight. A top-down view emphasizes symmetry and precision. From this angle, the fin layout and body alignment appear almost perfectly mirrored, reflecting strict engineering tolerances. This symmetry is critical for stable flight and predictable control response. Any imbalance at supersonic speeds could reduce accuracy or cause instability. The top view also highlights how compact systems are integrated seamlessly, demonstrating how modern missile design prioritizes efficiency and reliability over sheer size. A close-up of the engine area reveals the heart of the missile's power. The solid fuel rocket motor is designed for rapid acceleration, allowing the missile to reach combat speed almost immediately after launch. The internal grain structure of the fuel is optimized to provide consistent thrust throughout the engagement window. Around the engine, thermal insulation and structural reinforcements protect sensitive components from heat and vibration. This close-up view makes it clear that the propulsion system is not just about raw power, but controlled and predictable performance under extreme conditions. When examining the missile through an exposed or cutaway view, the complexity of its internal systems becomes evident. The guidance section contains sophisticated processors that analyze data from the infrared seeker and calculate interception paths in fractions of a second. Actuators connected to the fins and thrust vectoring system respond instantly to these calculations. The warhead section is carefully positioned to maximize effectiveness while maintaining overall balance. Wiring, sensors, and mechanical components are arranged with precision, ensuring redundancy and reliability. This internal layout demonstrates how modern missiles are essentially flying computers, combining software and hardware into a single integrated weapon system. The assembly process inside a manufacturing facility tells another important part of the story. In a clean, controlled industrial environment, skilled technicians and engineers assemble the missile in stages. Each component is inspected, tested, and calibrated before being integrated into the final system. Robotic tools and precision instruments are used to ensure exact alignment and secure connections. The assembly line reflects strict quality standards, as even minor imperfections could affect performance. Watching the missile take shape during assembly highlights the collaboration between human expertise and advanced manufacturing technology. What sets the Agile Darter apart is not just any single feature, but the way all these elements work together. The missile is designed for modern air combat scenarios where pilots rely on helmet-mounted sights and high off-boresight targeting. This allows a pilot to lock onto a target simply by looking at it, and the missile seeker and control systems handle the rest. The result is a weapon that dramatically increases engagement flexibility and survivability in close-range encounters. Beyond its technical characteristics, the Agile Darter represents a strategic achievement. It demonstrates that advanced missile technology is not limited to a handful of traditional defense powers. Through international cooperation and domestic innovation, South Africa has produced a missile capable of competing with the most respected short-range air-to-air missiles in the world. The design reflects lessons learned from decades of aerial combat evolution, emphasizing agility, resistance to countermeasures, and reliability. From every angle, front, side, back, top, and even inside, the Agile Darter tells a consistent story of precision engineering. Each view reveals a different aspect of its purpose, yet all contribute to a single goal: to provide pilots with a decisive advantage in the most demanding combat situations. Whether displayed at a defense exhibition, documented in technical visuals, or observed during assembly, the missile stands as a symbol of modern aerospace engineering and the future of short-range air combat technology.